This conference will now be recorded. This conference will now be
In the
recorded.
previous class, we were discussing things with respect to, let's say, one second. Okay. So let us begin. In the previous class, we were discussing things with respect to the peripherals, and we invested some time to have your doubts clarified. We saw the programming part with respect to the ADC, how to detect a single channel and how to detect multiple channels. You know that when it comes to the ADC, it may have multiple channels depending upon the ADC you have selected or depending upon the ADC available in your device, but there can only be one channel active at a time, as ADC is the only single device and its task is to convert an analog input what it takes to a digital output. So that work of the ADC will be done by a single block. The ADC takes an analog input from a sensor or any of an analog output providing device, and that output, whatever sensor give, that as it is taken as an input by the ADC, it is converted to a digital value and it is stored in the register of the ADC. Is my voice not clear? Okay. Vinita, every day this is a problem. Please check with your internet once. I'm not sure about the speed of your internet. Please check with your internet once, or maybe your mic is a problem. I'm not very sure. Okay. So after that, like we are done with the peripherals. As said, 80% of the complete module will be spent in learning the different peripherals, how to interface those peripherals with your own microcontroller, and how microcontroller will be able to communicate with those peripherals, how to take actions on those peripherals. We saw it in the previous class. So overall, if I have to list the peripherals we have discussed so far, we have learned something called as LED initially. Then after that, we did digital keypad. It's like a tactile switch, and it's a combination of multiple tactile switches. Then after that, we saw interrupts, and after interrupts, like first polling, then interrupts. Then after that, we saw the timers, then clock input output. Then we saw SSD, we saw CLCD, we saw matrix keypad, and also the ADC. Now, if you have a knowledge of good number of peripherals, how to interface them, how to be used with a particular microcontroller. So if you are able to configure it to this particular microcontroller, the one we are using, you should be able to interface it with any given microcontroller. You just have to know when to refer the data sheet, how to refer the data sheet, and how the peripherals are connected. You just have to know the schematic if you are taking a board, or if you are taking a peripheral of your own, how to establish the connection. So basic things, if you are known, you can have your code written, you can dump the code into the microcontroller, you can get it executed. So we are done with all the basic important peripherals, whichever is necessary. And today we are going to start with the next most important topic of this particular module, which is nothing but communication protocol. Okay, what difference will be there in 8, 16 or 32-bit microcontroller? Okay, the first difference is the size of the registers. So the registers can be a maximum of 8 bits if it is a 8-bit system. I mean a 8-bit microcontroller. Registers can be of 16 bits if it is a 16-bit microcontroller. 32 bits if it is a 32-bit microcontroller. Another difference is the amount of data it can process, transmit or receive at a time also depends on the bitness. So if it is a 8-bit microcontroller, you can transmit or receive 8 bits of data, like in the data bits. You can transmit or receive 8 bits of data. So that is the amount of data what your microcontroller can process at a time. Okay, fine. So moving ahead, today we have the next important topic. The very important topic I would say is the communication protocol. So you don't work with a single microcontroller. Some of the times you may have to work with different microcontrollers. You may have to work with multiple microcontrollers. So how to establish the communication between the two controllers or between the two chips, we will see with respect to the communication protocol. Now here in the communication protocol chapter, first we will look at the introduction to the communication protocols, the basic introduction to the communication protocols. Then after the introduction, we will start with the four important protocols to be discussing about. So first one is UART, second one is SPI, third one is I2C, and fourth one is CAN protocol. So we are going to learn these four protocols in detail one after the other, starting from today's session. Now coming to the introduction of the communication protocols, we have four questions to be understood about. First one is, what do you mean by communication? Second one is the different modes of communication. Third one is the different types of communication you're going to happen, and why exactly protocols are required. So these are the four questions we have to be knowing the answers for. Now initially to start with, we will go with what do you mean by communication? Now before I ask what exactly is a communication, do you think we are communicating right now? Do you think there is a communication happening between us right now? Yes. Then what do you mean by a communication? If we are communicating right now, what generally is a communication? Transfer of information, right? Any other answers? Transfer of data, okay. Are you people there? Please respond. What do you mean by communication in general? Is that just a transfer of data or transfer of information? Do you just transfer your data or information? Okay. Now, obviously, yes, transfer of data or information you convey, okay. It's a two-way, right? It's transmitting as well as receiving. Yes, I would say it's an exchange of information, isn't it? So interaction, right? So communication is just nothing but the exchange of information or data, sharing the data between two parties. So that is nothing but communication. So exchange of information or sharing the data between two parties, we generally call it as communication. Now, obviously, there has to be an exchange of data. There has to be sharing of the data between the two parties. We being the humans, what are the different ways we communicate with each other? What are the different ways we can communicate with each other? What are the different ways we can communicate with each other? We being humans. So I'm not asking just by one person to another, anybody. Okay. Hand. Okay. I see so many hand, eye signs, word. We speak, mobile, emails, letters, through senses. Okay. Speaking, using languages, face to face, telepathy. Okay. I'm good, getting so many crazy answers. Anyways, now if I have to keep it simple, if two persons have to communicate with each other, they either do it verbally by talking, or they may do it with respect to the text. Okay. So communication can happen with respect to the text as well. You can write and communicate, you can speak and communicate. Apart from speaking and writing, some people communicate with sign languages as well. So those who cannot speak, those who cannot hear, so people will communicate with some sign languages as well. So there are so many different ways of establishing the communication between the two parties. The question comes is, You know what is communication? You know how we people communicate with each other. But the major question is, why is the communication required? Why is the communication required? Like, why should we be communicating with each other? Why do you think we have to communicate with each other? What is the reason? Establish the contact, okay, to get what we need, fine, to express, okay. Now, please understand, if there is a communication to happen, there should always be a need. Unless and until there is no need, the communication will never happen. So, the ideology behind or the thing behind communication is always something with respect to the need. Now, for example, I am communicating with you people, or you are communicating with me. So that is because there is a need. The need is I want to teach you microcontroller and you want to learn microcontroller. So there is a need for both of us. So only when there is a need, communication is happening. Now, for example, if I didn't have to teach you the microcontrollers, or if you didn't have to learn microcontroller, there would never be a communication between us. So communication always comes when there is a need. Or if I go with one more example, assume you are in a wedding hall. Okay. So boys especially go to a wedding on a very rare times. So assume you still went to the wedding with your parents or with somebody who you know, and you are sitting in one corner. The one who you went with is roaming around in the hall. So you are being alone. Now if you are an introvert person that you don't like speaking to others, so you don't you don't like to interact with people generally. Now assume the biggest problem here is you have forgotten your phone, because that's when there is a phone, obviously even if there is a need of communication, you will be so much involved in your phone. Now just an assumption that you have left your phone, assumption obviously, because you people will never forget to take the phone wherever you're going. So saying it as an assumption, assume you have forgotten your phone, you have went to a wedding and nobody is there to speak to you. It's like people are busy with each other's work and you are being sitting alone. Assume somebody very similar to you sitting just next to you. Now what will you do? Like when you are sitting alone, do you continue to sit alone at that time also? Do you still continue to sit alone? Or will you at least go from that place? Okay, you're not allowed, you cannot go from that place. You have to wait till the person you went with is coming back. Okay, I would say the least you can do is talk to the next person, right? You're so bored, you're so I would say so bored and you don't have anything to do. The least what you can do is talk to another person who is sitting next to you, right? Yes, you will try to communicate. So there also is a need. The need is you want to get rid of your board. So you need that bonus to be went off. So every communication internally or externally, there is a need associated to it. Only if there is a need, communication is going to happen. Okay. So that is nothing but communication. Communication is just nothing but the way of exchange of information between two parties. Now I can understand that we people or humans tend to communicate with each other. Obviously, when you have learned something to be spreading about, so if you don't spread it, it is a waste of what you have learned. So obviously, to have the data exchange, you will definitely do the communication. I can understand it with respect to the human. But why do you think the machines have to communicate with each other? why should a machine communicate with each other? Why should two devices communicate with each other? Now, for that example, let me speak about an example which we have already discussed. So, the example what I'm going to take is an automatic water pumping system. Do you remember we tried designing an automatic water pumping system? Okay. Now I'll go with a similar, the same example in fact. So the question is, you have to design an automatic water pumping system. Automatic water pumping system. And the requirements as taken earlier, you have to turn on the pump exactly at 8 a.m. Okay. So turn on exactly at 8 a.m. and after you turn on exactly at 8 a.m., it has to be kept active for 1 hour. Okay. So it has to be kept active for 1 hour. So that is automatic water pumping system. Okay. And in case of automatic water pumping system, so you have to turn on the pump exactly at 8 a.m. for a duration of 1 hour. Now, let us list out the most important components of designing of designing this embedded system. Which one is the most important component? Okay, so yes, that's the microcontroller. So assume I'm going to take the microcontroller here. So the microcontroller is the RPIC16F877, or you can choose any of a given microcontroller. After this, what is the next important component? Come on, what else do you need? Okay, so to take the action, I need the pump. Okay, and I will not consider which pump it is, which motor it is. So I'm going to consider it as relay. Okay, so what this microcontroller has to do is it has to instruct the relay to turn on the pump exactly at 8 a.m. Now, to make sure the pump is turned on exactly at 8 a.m., what does it need? What do I need to achieve the time of exact 8 a.m.? Come on, what do I need to achieve the time exactly at 8 a.m.? Okay, timer. Now you know that most of the microcontroller, in fact every microcontroller will have at least one timer built in. Okay, most of the microcontroller will have at least one timer built in. So assume I'm going to make use of the built-in timer. Now, what you have to do is you have to provide the timer. So timer is counting the time. When it is 8 a.m., microcontroller will instruct the relay to turn on the pump. And after a duration of 1 hour, again microcontroller will instruct the relay to turn it off. Okay. So what we have tried designing is an automatic water pumping system. Now, if I have it designed to a Indian farm, do you think power supply will be provided continuously? Will it be available for 24/7? No, it will not be available. So as a safety backup, I'm going to provide battery connected. So like this, I'm going to have a battery connected. Okay. So we have the battery connection done like this. Okay. Now, if the power supply is not available for 24/7, if the power supply is available, then the power supply will be used. And if the power supply is not available, then battery will be used. Okay. Now, for how much of duration this this system has to be active? For how much of duration the system has to be active? For a duration of 1 hour. So what happens is, whenever your system is being turned on, the microcontroller should start counting the time. Okay, and once the time says it is 8 o'clock, so the timer which is in the microcontroller will be helping the microcontroller to tell the relay to turn on the pump. Now after a duration of 1 hour, again microcontroller should instruct the relay to turn off. So the whole system should actually be active for a duration of 1 hour only. Now in the rest of the 23 hours, can I put my microcontroller to the sleep mode to save some power? Can I put the microcontroller to sleep mode to save some power? Yes. Okay. Now if I put my microcontroller to the sleep mode, do you think timer will still be able to count the time? If your microcontroller is sleeping, I have taken a timer which is available inside the microcontroller. Now, if the microcontroller is made to sleep, do you think the timer will still be able to calculate the time? No, that is not possible. So, because I'm using the built-in timer, I am going to have the microcontroller kept turned on for complete 24 hours. Now, I'm not using the power efficiently. So, data is not being used, sorry, the microcontroller's power is not being used efficiently. Now, I have to offload the work of the timer. Offload in the sense, you just have to make it free. You have to let the microcontroller be itself. So, you have to offload it. Now, when you are offloading, instead of using the built-in timer of the microcontroller, you are going to make use of RTC, which stands for real-time clock. Now, the biggest advantage of RTC is, remember, it can be separately battery backed up. So, you don't have to get the source from the microcontroller itself all the time. So it can be separately battery backed up, and it consumes very less power compared to all other peripherals. So I'm going to make use of RTC in order to make this happen. Okay, so this is RTC. Now this RTC is connected to the microcontroller. Now instead of you using the timer, instead of me using the timer, I'm going to make use of the RTC. Now what happens with the RTC is, so the timer of the microcontroller is being offloaded, and that work is being given to the RTC right now. So it's the RTC who is calculating the time right now. Now RTC starts counting the time. Assume your microcontroller is initially sleeping. So RTC started counting the time, and exactly at 8 a.m., RTC will go instruct the microcontroller. It will wake the microcontroller up and say it is 8 a.m. Something like, let's say you are sleeping, and maybe your mother will come and like, so you have given a duty to your mother. Okay. So the duty of your mom is to wake you up exactly at, let's say, 8 a.m. in the morning. So you are in a very good deep sleep. Your mom comes and wakes you up exactly at 8 a.m. Just assume. Now, don't you ask your mother, why are you waking up? So even though you are in a you are still in a sleepy mode, and when your mother asks you to wake up, will you not tell your mother, like, don't you ask your mother, why are you waking me up? Something like that. Don't you generally ask? Or you get up the moment your mom wakes you up? Is that so? Guys, are you able to hear me? You will. Okay. So definitely we generally ask. Okay. So we are generally going to ask your the people, why are you going to wake me up? So very similar to that, when RTC tries waking the microcontroller up, So RTC is coming to communicate with the microcontroller. Similarly, when RTC is waking the microcontroller up, your microcontroller may ask the RTC also, why are you waking me up? So my RTC responds to the microcontroller saying, you asked me to wake you up at 8 a.m. So I have woken you up at 8 a.m. Now it is your task to go ahead and perform the other operations. So microcontroller will wake up, turn on the relay, instruct the relay to turn on the pump, and after a duration of 1 hour, again RTC instructs the microcontroller, 1 hour of duration is done, and microcontroller instructs the relay to turn off the pump. So something like that. Whenever you are going to uh, say anything, you need a communication to happen. So here also, RTC is a separate chip, microcontroller is a separate chip. When you want to establish the system with the help of these two different chips, so they are like two different systems, and there is a need for you to communicate with each other. So there is a need for the systems also to communicate with each other. Are you able to follow this? Okay. So generally, why systems have to communicate is if you are trying to offload your main system, then whatever other components are doing the work, to make sure it is done or to show the work is been complete, the systems have to communicate with each other. So why should you offload the system is to make sure the work is managed on a efficient manner. So that is nothing but why the communication is required. Now coming back here, the first question was what do you mean by communication? Together with that, you also understand why should systems communicate with each other. Any doubts in this? RTC is it uses external clock, right? Is the only difference between RTC and timer is built in and RTC is external component. Other than this, is there any other difference? Um, so RTC is actually real-time clock. So it is going to work according to the crystal frequency, according to the instruction cycle of the system itself. So the major difference, as I said, it's a separate chip. It doesn't come with a device. It's a separate chip, and programming RTC is very simple, in fact. And when it comes to the RTC, as I said, it will consume very less power compared to all other peripherals. So that's an advantage. But apart from that, there is no much difference. RTC is always meant to calculate the time. That's it. Okay. Can we proceed? I'm sorry. Clock, that depends. It depends on, there is no external clock. There will be an oscillator built in which will generally be disabled. So you have to turn on that oscillator. So oscillator is going to take the oscillating frequency, and accordingly the time will be calculated. Okay, moving ahead. So after the first question, what is communication? The next question is different modes of communication. So can you tell the different modes of communication? What are the different modes of communication? Okay, yes. So when it comes to the modes of communication, you have three modes of communication. One is simplex, the second one is half duplex, and the third one is full duplex. Okay, so these are the three different modes of communication. Now, what happens in case of simplex mode of communication? What happens in the simplex mode of communication? Yes, it's a one-way communication. Okay. So one-way communication in the sense one has to transmit, the other has to receive. It's a one-way communication. So only one can transmit all the time, the other one can receive all the time. So it's a one-way communication. Can you give the examples for one-way communication? That means the simplex. Any examples for simplex? Yes. So radio broadcasting. So that is simplex. Okay. Sensors. You cannot say it as a communication happening. You're just reading. So communication is something you call when there is happening between two chips. These are simple peripherals. They are not two different chips. Walkie-talkie is not a simplex. So whatever radio broadcasting, so your television broadcasting, so they all are simplex where there is one way transmission, the other one is receiving. That's it. Now what is half duplex? What is half duplex? Come on, what is half duplex? Yes. So half duplex is nothing but two-way communication, but only one can communicate at a time. Okay. So half duplex is two-way communication, but one can communicate at a time. So two-way communication. Okay. One at a time. So that is half duplex. There will be two-way communication, but only one can communicate at a time. Now the example of half duplex is you can say there is walkie-talkie. Yes. So that's a best example for half duplex. One will communicate, the other one will receive. The other will communicate, the first one will receive. So two-way communication can happen, but only one can communicate at a time. Then third one is full duplex. Okay. And in case of full duplex, it is two-way communication. Okay. So it's a two-way communication and both can communicate at a same time. Both at same time. So can you give the examples for full duplex? Yes, the mobile phones, the telephones. So all of them are the examples of two-way communication where both can communicate at the same time. Okay, so that is full duplex. So to understand the communication protocols, these terminologies are important. So if I say a communication protocol is simplex, you have to understand how the communication is happening. If I say it as half duplex, you have to understand. So you have to remember this. The three modes of communication are simplex, half duplex, and full duplex. Simplex is one-way communication. Half duplex is two-way communication, but only one can communicate at a time. And full duplex is two-way communication and both can communicate at the same time. Understood this? Okay. So after this, the next one is nothing but I would say types of communication. Can you give me some of the types of communication? What are the different types of communication? Okay. One is synchronous and asynchronous. Okay. One is synchronous, the other one is asynchronous. Then any other types? Any other types of communication you have known? Guys, do you know any other types of communication apart from synchronous and asynchronous? Okay. Have you heard of serial and parallel communication? Serial and parallel communication. Okay. So apart from that, we also have something called as wired and wireless communication. Then we have analog and digital communication. So there are so many types. I don't want to discuss all of them. So very commonly heard is these two types. So let us discuss only these two. Serial and analog and digital is in analog you transmit 2.5 volts, 3.5 volts, something like that. In digital it is 0, 1 only you are going to transmit. Then wired and wireless is where the connection is established hardware with the wire. It is wired communication. If the connection is happening through Ethernet or the network, so we call it as wireless communication. Now, all the communication protocols we are going to study are wired communication. Okay, so you are going to establish the communication with the help of wires. They are wired communication. Now, what is the difference between serial and parallel communication? When it comes to serial, how many bits can you transmit at a time? How many bits can you transmit at a time in serial communication? Yes. So, one bit can be transmitted at a time. One bit is 1 bit at a time. But when it comes to the parallel communication, how many bits you can transmit at a time? You can transmit more than 1 bit. I would say n number of bits. Okay. So n bits at a time you can transmit. So in case of serial communication, you can transmit 1 bit at a time. In parallel communication, you can transmit n bits at a time. So that's the first difference between serial and parallel communication. Now, which one do you think is faster between the two? So is serial communication faster or parallel communication? Yes, always parallel communication is faster compared to that of serial communication. Now, assume there is a data which needs to be transmitted and the data is of 8 bits. Okay, so data is of 8 bits. Now assume the time constraint I say is 1 microsecond. Okay, so at once the time I'm going to consume is 1 microsecond. Now if it is serial communication, to transmit 8 bits of data, how much time is it going to take? Yes, it is going to take 8 microseconds to transmit 8 bits of data. So one time 1 microsecond if I consider, 8 bits needs to be transmitted for 8 times. So it is going to occupy 8 microseconds in total. But when it comes to the parallel communication, all 8 bits can be transmitted in 1 microsecond itself. So serial and parallel communication, if you compare, serial communication is comparatively slower. Parallel communication is always faster compared to that of serial communication. But what do you think is the difference between serial and parallel communication? What is the difference between serial and the disadvantage? What do you think is the disadvantage in parallel communication? The disadvantage of serial communication is it consumes more time. What is the disadvantage of parallel communication? Yes. So in case of parallel communication, it requires more number of hardware lines for the data transmission to happen. So parallel communication has something called as the hardware complexity. So more the number of bits you want to transmit at a time, more will be the hardware complexity. Okay. So if for example I want to transmit 8 bits at once, I should have 8 data lines to transmit the data. If I have to transmit 15 bits at once, I need 15 bits of 15 hardware lines to have the data transmission done. So if you are using parallel communication, parallel type of communication, So you can see that the hardware complexity is more. And because of this hardware complexity, people still deny or back out using the parallel communication. I can understand it is comparatively faster, but due to the hardware complexity, parallel communication is generally not preferred. Now, because serial communication is like very extensively used in everyone's day-to-day life, so I cannot let serial communication take 8 microseconds just to transmit 8 bits of data. So several advancements and improvements are being made on serial communication, that it takes very few time to get 1 bit of data transmitted. So the advancements are being made, the upgradations are being made, and due to that, as of now, the serial communication can also be comparatively faster compared to the older serial communication, and you can literally transmit like more number of data in less amount of time. So as of now, if you take this example, it is taking 8 microseconds, but you can see some of the serial communication which happens in few nanoseconds also. So improvements and upgradations are being made on serial communication, as most of the people are used to use the serial communication these days. Is that clear? Okay. So after this, we have synchronous and asynchronous communication. What is the difference between the two? What is the difference between synchronous and asynchronous communication? What happens in synchronous communication? Yes. So in case of synchronous communication, communication is happening with respect to the clock pulse. Now, synchronous communication is happening when you want to maintain the proper sync of the data. So, the synchronous communication happens with respect to the clock signal. Both transmission and reception happens with respect to the clock signal. So, generally, clock signal will be generated by a device called as the master. So, it's the microcontroller which is called as the master. So master generates the clock pulse, and after the master generating the clock pulse, the communication is going to happen between the two devices. So communication happens with respect to the clock pulse on a synchronous manner in case of synchronous communication. And in case of asynchronous communication, there is no clock pulse. Okay, so there is no clock pulse, and because there is no clock pulse, okay, so asynchronous communication is happening, so there is no clock pulse in case of asynchronous communication. Now, because there is an absence of the clock pulse, what you have to do is you may need some of the triggering mechanism. Okay, so you may need some of the triggering mechanism in case of the asynchronous communication. So there is no clock pulse involved, and there is a triggering mechanism which is required to seek the attention of the receiver when you are trying to do the communication. So here, in case of asynchronous communication, the receiver must have been busy with some other task, or receiver must have been sleeping to save the power. So in that case, to seek the attention of the receiver, you have to use any of a triggering mechanism to wake the system up. So that is asynchronous and synchronous communication. Trigger is generated by the master. Yes. So whoever wants to start the communication should be triggering the system. So generally, when we are using asynchronous communication, we don't refer the terms as master and slave. So it's like a device. Whoever wants to start the communication will be the very first, I would say, host. So the one who wants to start communication is going to have the uh, um, triggering mechanism done. Means the microcontroller here. Yes. So if microcontroller wants to communicate, it should be the microcontroller who will seek the attention of the receiver. Okay. So that is the difference between synchronous and asynchronous communication. Any doubts in this? Okay. Now after the types of communication, the next question is why protocols? Now before I ask you why protocols, what is a protocol? What exactly is a protocol? Why is there a very low response today? People are not active. Okay, some mandatory guidelines. Okay, so standard to communicate. Okay, set of rules. Yes. So protocols, we generally call them as set of rules to be followed while the communication should be happening. Okay, so set of rules generally are called as protocols. Now the question comes is, do we follow all the protocols being set? I mean, do we humans follow all the rules whichever are being set to us? No, right? Obviously, no. Whichever we feel like we can follow or we have to be following, we follow them. And sometimes we ignore some of the protocols also. So there are chances where we humans will skip some of the protocols. We don't take care of some of the protocols. Now, what happens? Yeah. So mostly helmet. That is right. So people don't wear helmet when they are asked to, and even though there is a skywalk, people don't use the skywalk to cross the road. They still cross the road directly on the road. So like this, like generally people ignore some of the protocols which are being set. But sometimes we cannot ignore those protocols. It is very important. For example, let's say the protocol given to me from my offices, I have to take class in English. Okay. So ours, especially in India, because it's a very diversified country with so many languages being spoken from one country, one state to another state. So I am strictly supposed to follow that I speak in English while taking the class. So that's the protocol being set to me. Now, if I say no, I don't want to follow this protocol and I'll be speaking in my mother tongue, let's say Kannada. So I will start speaking in my mother tongue. Do you think will all of you will be able to understand whatever I'm speaking? Obviously, no. Not everybody here will be able to understand what I speak. So it is very important when certain things has to happen. So you have to make sure I have to follow certain protocols, certain rules. So here also, see, we being humans may ignore some of the protocols, but that cannot happen in case of two systems. When two systems have to communicate with each other, there are certain protocols given for them also. Some procedure to be followed while the two systems are communicating with each other. So that we call it as protocol. Different company wrote different rules to be followed while the communication is established between two chips. Now, the first communication protocol we will be discussing is UART, and UART is a protocol which was designed by the Intel company. Okay, so it was by the Intel company. UART was a communication protocol given by the Intel company. They wrote certain rules to be followed while the communication between two chips have to happen. So that is UART. Then there is SPI, which was by the Motorola company. Okay, so they also have given certain rules to be followed while communication is happening. Then there is I2C, which was by the Philips company. So Philips right now is being called as NXP. Okay, So that is by the Philips company. And we have CAN protocol, the rules to be followed when two systems are communicating. And this was by the Robert Bosch. Okay, so this was by the Robert Bosch. So these are the communication protocols we are going to learn throughout our module. And all of these communication protocols are wired, and all of these communication protocols are serial protocols. Okay, so we are going to learn all serial communication protocols from here onwards, starting from UART. Now, before I start with the UART communication protocol, there's one small topic called as inter let's CPU. The CPU is the one which is actually communicating using parallel communication. Okay, parallel communication is already happening on your CPUs. Okay, fine. So let us proceed ahead. So the next we have to be discussing about is interpersonal communication. Means processors use parallel. Yes, so generally not all the processors use parallel communication. Even there are processors which will use serial communication. It depends on what like through which the communication is happening. Okay, so if the two devices, if the other device support only serial communication, it has to go with serial communication. If there is a support of parallel communication can happen. Okay, so inter-process communication, yeah. So process it is, yes. So through HDMI cable, yes, you can have the parallel communication done. Okay. So moving ahead, the next we have is a small topic called as inter-board communication protocol and intra-board. Serial taking more time than serial only, widely used. Why so? As I said, so serial communications advantages, the hardware complexity is really less. And one more thing is, now because the hardware complexity is less, so people started using serial communication, and these days there are so much advancements being made that even serial communication communicates comparatively faster, okay, than the older serial communication usually used to do. Okay, so advancements are being made on serial communications as well, and these days serial communication also communicate on a faster rate. So just due to the disadvantage of hardware complexity, people use serial communication. Okay. So one last thing, theoretically, with respect to the communication protocols, we have a category called as interboard protocol and intraboard protocol. Interboard protocol. Okay. The other one is intraboard. Intraboard protocol. Now, what is the difference between the two is when you have to choose between. So, okay. So when you have to choose the protocols by yourself, when you have to establish communicating between the two systems, you have to take care of interboard and intraboard communication protocols. Now, what is the difference between the two is interboard communication protocol will be used when you have to communicate between two chips of different board. Okay, two chips of different board. So let's say there is one chip here. This is one board. This board has one chip. There is one more board, and that has another chip. Now you want to establish the communication between these two chips of two different boards. Okay, that is inter-board protocol. You have to choose a protocol which supports inter-board protocol. Now the example for inter-board protocol is one we have that is UART, the other one is CAN. So both UART and CAN are inter-board protocols. The second one is intra-board protocol, where the communication is happening between two chips of the same board. So like this, there will be one board which will have two different chips. So communication is happening between two chips of the same board. Then you have to choose any of a intra-board protocol. So I would say two chips of same board. Okay, when you have to establish the communication between two chips of same board, you have to choose any of a inter-board protocol. Now if you want to establish communication between two chips of two different boards, you cannot use any of an intra-board protocol. So you should have a knowledge when to use which protocol. So examples of intra-board protocol are SPI and I2C. Okay, so in case of inter-board protocol, the communication happens between two chips of two different boards. Intra-board protocol, communication will happen between two chips of the same board. So depending on the communication you want to establish, you have to choose the communication protocol. And this is about the theory of the communication protocol. Any doubts? Okay. So take a break of 2 minutes. We will start with the first communication protocol. Okay. Can we proceed? Fine. So, moving ahead, we're going to start with the very first communication protocol. So, first, we will speak only with respect to the ideology or what exactly is this protocol. Then, programming part we will see in the next class. So, initially, to start with, the very first communication protocol we are going to start is UART. And UART is a communication protocol that was introduced by the Intel company. And coming to the UART communication protocol, we have got these many things to be discussing about. First, we have to know the introduction to the UART protocol, then how interfacing is done with the help of UART, how the hardware configuration is established, and what exactly is the frame format of the protocol. So we will learn all of this in detail. Then we will establish the communication between two chips and see how it is working in the software as well. Now coming to the UART protocol. What do you mean by UART? So what do you mean by UART? Yes. So UART is nothing but Universal Asynchronous Receiver and Transmitter. Okay. So UART stands for Universal Asynchronous Receiver and Transmitter. Sometimes people also refer it as UART. So there is also called as sorry. Okay. So there is also something called as UART. People generally refer this also, and UART stands for Universal Synchronous Asynchronous Receiver and Transmitter, where it will have both the modes. It will have synchronous mode. It will also have an asynchronous mode. So depending on the requirement, you have to choose which mode you want to go for. So generally the very commonly used is UART, which is Universal Asynchronous Receiver and Transmitter. Now, speaking about the functionalities or characteristics of the UART protocol, first one, it's an asynchronous protocol. Now, what do you mean by asynchronous protocol? So asynchronous means what is absent, especially. Yes, there is no clock signal when it comes to the asynchronous protocol. It's not no trigger. So if there is no clock, you have to go for a triggering mechanism. So no trigger is wrong. Okay, you have to make use of trigger. There is trigger, yes. So in case of asynchronous protocol, it's a communication protocol which doesn't involve any of a clock pulse. Now, because it doesn't involve any of a clock pulse, remember you need any one of a triggering mechanism to seek the attention of the receiver. Now, the duplexity is any. You can either achieve half duplex, you can achieve full duplex, but when it comes to the half duplex, the thing is two-way communication obviously, but one can communicate at a time. But in case of full duplex, there is two-way communication where both can communicate at the same time. Now, generally, when you are given with an option of half duplex and full duplex, which one will you choose always? It is always a full duplex. Okay. So here also, when I'm given with an option of half duplexity and full duplexity, I will always prefer choosing a full duplexity. Now, in order to achieve full duplexity, how many lines do you think is required? How many lines for the communication is required to achieve full duplexity? So one has to transmit. I don't need four. If one is transmitting, the other can receive. The other is transmitting, the first one can receive. So in order to achieve full duplexity, I need two lines for the data transmission. A maximum of two lines. You don't need four lines. Two lines are sufficient in order to achieve the full duplexity. So one will be transmitting, the other one will be receiving. So if the second one is transmitting, first one will be able to receive. So two lines are enough. Then we have the terminologies as master and slave. In fact, When it comes to the UART communication protocol, we generally don't refer the devices as master and slave, because you call a device as a master only if it generates a clock pulse. Now, do I have a clock pulse involved in UART? Do I have a clock pulse? No, I don't have a clock pulse involved. Now, if I don't have a clock pulse, there is no clock pulse generation. Why will I refer a device as a master? So there is no need of referring the device as a master and a slave in case of UART protocol. You can refer them as host and devices. So the one who wants to transmit the data, you can call it as host. The one who receives the data, you can call it as device. So generally, in case of UART communication protocol, we don't say them as master and slave. We call them as host and devices. So these are the features of the UART protocol. Now, the next thing, so as I said, in order to achieve full duplexity, I will need two data lines. So you can see the names of the data lines. Every device will have a transmitter. It will have a receiver. Receiver to receive the data, transmitter to transmit the data. Because you may want to establish two-way communication at the same time. So every device will have a transmitter and a receiver. Now, if you look at the hardware configuration, there are two devices. Okay, so here you can see there are two devices, and please look at the direction of the line. So here, this is the very first device which wants to transmit. If the first device wants to transmit, the second device has to receive. So first device is the transmit, second device is the receive. And the arrow is from device 1 to device 2. So device 1 transmits, device 2 receives. Okay. So device 1 is going to transmit the data, device 2 is receiving the data. That is one side. On the other side, when it comes to device 2, when device 2 is transmitting, device 1 is receiving. So you can see the pin names, transmitter for device 2, receiver for device 1. And if you look at the arrow, it is from device 2 to device 1. Okay, you have to remember the names of the pin, you have to remember the direction of the line. So if device 1 is transmitting, device 2 will be receiving. Device 2 is transmitting, device 1 is receiving. As of now, we have kept the names as devices. We don't have it referred as host and a device, because we don't know who wants to transmit and who should be receiving. It can either be device 1 who transmits, it can be device 2 who transmits. Now, whoever wants to transmit will be considered as host, the other one will be considered as a device. Now these are the two devices. Device 1 transmits, device 2 receives, device 2 transmits, device 1 receives. Now after the hardware connection is established, we have to start the communication. So when something has to be transmitted, we make use of something called as the frame. When we have a data to be transmitted, we are going to make use of a frame. Now, what is that frame, or how is that frame formed? Let us look here. Okay. Now, so I have two devices. So this is device 1. Okay. And this is device 2. So I have two devices. Let me name the two devices. This is device 1. Okay. And this is device 1. This is device 2. Okay. Now two devices wants to communicate with each other. So device 1, if it transmits, device 2 should be receiving. So I'm going to take care of the arrows and also the names of the pins. Okay. So this is the transmitter of the first device, TX, and this is the receiver in the device 2. Okay, receiver. And if this is the transmitter of device 2, this will be the receiver of device 1. Okay. Next, not just this. So when the communication should get established between these two devices, both the devices should be commonly connected to ground. So that is important. When you are trying to achieve UART communication protocol, the two devices have to establish a common ground connection. Okay, so it's something like this. So I have two devices. So that is how the like it is a protocol, the rules you have to follow while having the communication established. So there is no reason why we call this as a transmitter, this as a receiver, why we call it as a host and a device. Everything is like it has been written by the Intel people. So it's the procedure you have to follow. If you have different boards, it is not possible. So like when you have two different boards, so obviously your communication UART is an example for interboard communication protocol, where you are trying to establish the connection between two different boards, chips of two different boards. So in that case, if you are at least not commonly connecting it to ground, there will be a connection being made between two, let's say, uh, devices. So they have to be given to ground. Okay, if not common, at least you have to make sure they are connected to ground for safety purpose. Okay, now, so I have two devices, one is transmitting, the other one is receiving, and second one is receiving, the first one is transmitting. Okay, individual ground also is okay. Actually, you have to provide ground in common, because we speak things with respect to the baud rate, bit rate, and all. Now, generally, when you are establishing the communication between two chips, they will be closer to each other because you have to make the hardware connection. So you have to provide the ground in common. So both of them should be provided to ground in common. Individual ground, in the sense, both of them should be given with like, it is fine if it is a very farther distance, it is still fine, but ground should be provided for the two devices. Okay. Now, so once you're done establishing once you're done establishing the hardware connection, the communication has to start. Now assume the data I have got to transmit. A device has to transmit is, let's say, 0x25. This is the data to be transmitted. Now, how to represent 0x25 in binary? It's a serial communication. The transmission happens bit by bit. Okay, it's a serial communication and transmission happens bit by bit. So 25 is 00100101. So this is 25. Now, do you think I will directly start transmitting my data? Will I directly start transmitting my data where after the connection is established? No. So there is no clock pulse involved. So I have to make use of a triggering mechanism. Now, before I start transmitting the data, the first thing I'm going to transmit is something called as a start bit. Okay, a start bit will be transmitted, and generally the start bit will always be a 0. Okay, whoever wants to start the communication, so that device is going to transmit a 0 at first. So that's a start bit. Okay, now once the start bit is transmitted, all the devices in the network are going to receive it. Now, whoever is going to receive, so now the communication is established between two devices in the network. There is device 1, there is device 2. Assume device 1 wants to communicate with device 2. I'm sorry, not all the devices in the network. There are only two devices in the network, device 1 and device 2. So device 1 starts transmitting the data. It first transmits a start bit. Device 2 is going to receive that. Now once device 2 receives it, it pays attention to the data which is being received. Okay, which it has to receive. Now it pays attention. So it wakes up, it pays attention to the next data it is going to collect. Now that device 1 has triggered the device 2, it can start transmitting the data. It transmits the data from D0 bit, the least significant bit. So first D0, then D1. Okay, so D0, D1, then D2, D3, then D4, D5, D6, D7. Like this, it transmits the data bit. Now, once it is done transmitting the data bit, it's the duty of the device 1 to also say it is done transmitting the data. So, it is going to transmit a stop bit. Okay, it transmits a stop bit. And generally, stop bit are two high bits, that is 1 and a 1. Okay, first it transmits a start bit, then 8 data bits and a stop bit. Okay, now assume device 1 transmits the start bit, device 2 receives it, then device 1 transmits D0 to D7 bit, device 2 is going to receive it. Now, how will device 2 confirm whether the data it has received is right or wrong? How will the device 2 know whether the data received is correct or not? Come on. How will it know? An acknowledgement. We don't take an acknowledgement is like you will say that it has received, but how to confirm whether the data is received or not? Yes. So we have something called as the parity bit. Okay. Before transmitting the start bit, it is going to transmit a parity bit, which is either a 0 or a 1. Okay. Only then it transmits a stop bit. So first it is going to transmit a start bit, then it transmits a 8 data bits, 1 parity bit and a stop bit. Now what is this parity is? It is the count of number of ones. Okay, so it represents the number of ones in the given data. Now if the parity only 8 bits can be transmitted. Yes, so only 8 bits can be transmitted. So there is one more chance. Depending on the device, you can transmit 9 bits. You can transmit lesser number of bits also. But generally, it is meant to transmit 1 byte of data. That is 8 bits at a time, like in one frame. Okay. So parity is representing the number of ones. Okay, parity always represents the number of ones. So we have odd parity representing the value 1 and even parity represents the value 0. Odd parity represents the value 1 and even parity represents the value 0. Means if there are even number of ones, it is even parity. If there are odd number of ones, there is odd parity. But with parity, one parity bit check, it same or not right. But for remaining bits, what is the confirmation? So parity, as I'm saying, is the number of ones in your given data. So this is the only way. This was the very oldest communication protocol which had just a parity bit. It will just say how many like whether you have odd number of ones or even number of ones. Okay, that is parity bit. So parity is 1 represents odd parity, means it has odd number of ones. Parity is 0 represents it has even number of ones. Now first it has to transmit a start bit, 8 data bits, 1 parity bit and 2 stop bits. Now let me transmit the data 0x25. First it is first it is a start bit. Okay, so I'm going to transmit a start bit which is a 0. Then I have to transmit the 8 data bits starting from LSD. So it is D0 bit first. So first I will transmit 1. Okay, it's D0 bit first, data 0 bit. Then you transmit 0. Or if you want, you can transmit the data directly like this. So 0, 0, 1, 0. Okay. So and it is 0, 1, 0, 1. So like this you transmit 8 data bits. Now after you transmit 8 data bits, I have to transmit a parity bit. So what is the parity bit according to the data I'm transmitting right now? Is it a odd parity or a even parity? It's a odd parity. So I have to transmit a 1. Then 2 stop bits have to be transmitted. So this is how data transmission happens. A start bit, 8 data bits, 1 parity bit and the stop bit. So you can observe here, okay, frame format. So 1 start bit, 8 data bits, 1 parity bit and 2 stop bits. So start bit is a 0 always, stop bit is 2 ones always. So 8 data bits can either be a 0 or a 1 and parity bit can also be a 0 or a 1. So how parity is 1 is, in my data 0x25, if you observe, I have 3 ones. So odd number of ones, so it represents odd parity. So because it is odd parity, I have to write 1 in the parity bit. Okay, fine. So this is about the frame format, what gets transmitted when it comes to the microcontroller. Now, if you can see here, this is the frame format. So coming to this, the data part can be 5 to 9 bits. So as I said, you can transmit 9 bits of data also. In that case, you are going to make a compromising on parity bit. So you will tell that you don't want to transmit the parity bit. So assume I have 9 bits of data to be transmitted. I cannot take one more frame format for that. Instead, I will tell I will compromise with the parity bit and I will be transmitting one more data bit. So that is possible. Minimum of 5 data bits and a maximum of 9 data bits can be transmitted. So stop bits could be 2 bits, it is 2 ones, and parity bit can either be a 0 or a 1. Okay, so that is nothing but the frame format of UART protocol. Clear? Okay, so one more thing, this tells things with respect to the baud rate. So baud, okay, so within 8 bits we have to send all. No, 8 is the data bit size. So 1 second. So 8 is the data bit size. 8 data bits except the start, parity and stop. So I'm speaking about 8 complete data bits. Data frame is, yes, either you call it as just a frame or data frame, it's the same. You are transmitting data itself with the help of this frame. Okay. Now the next thing is, it is talking about the baud rate. So baud rate is nothing but the rate at which the data gets transmitted or the rate at which the data gets received. So baud rate sometimes will also be referred as bit rate, means number of bits which gets transmitted per second. So baud rate is number of symbols being transmitted per second. So each symbol can either have a single bit or it can have multiple bits depending on the different modulation techniques. Okay, so number of symbols being transmitted per second is called as baud rate. Number of bits being transmitted per second is called as bit rate. So symbols may have one bit sometimes. Symbols may be made up of multiple bits with the help of any of a modulation technique. Now, if I have to give a correlation with respect to the baud rate and the bit rate, okay, so I can say it like this. Baud rate is equal to then there should be baud rate or a bit rate generated. Yes. So any of a device will obviously will have a baud rate or a bit rate generated. It is actually baud rate. So in most of the cases, we've fixed to have the same baud rate. Okay. So the formula is, I'm sorry, bit rate is equal to n multiplied by baud rate. So number of symbols per second, I would say. Number of symbols multiplied by baud rate. Okay. So bit rate is number of symbols multiplied by baud rate. So you can see a correlation here. So this is baud rate versus the bit rate. So first one is nothing but in 1 second. Okay. So here in one time, okay, there is only one bit being transmitted. Okay, in this case baud rate and bit rate are same. Okay, in the first scenario baud rate and bit rate are the same. So in 1 second there is only one bit being transmitted, so one symbol is made up of only one bit. Okay, so in the first case baud rate and bit rate are the same. Okay, I would maybe write it here. So first of all baud bit rate, I'll write it as bi. Okay, is nothing but n multiplied by baud rate. Okay, ba I will write. Okay, so here baud rate is number of symbols per second. In the first scenario I have 10 symbols per second, so it is 10 multiplied by, each symbol is made up of only one bit, so it is 10. So bit rate in the first scenario is same as that of the baud rate because each symbol is made up of a single bit. Now with the help of any modulation technique, I can have multiple bits taken in a single symbol. You can see here one symbol has two bits. Okay, this is one symbol which is representing two bits. One symbol having two bits, one symbol having two bits. So in the second scenario, bit rate is nothing but n multiplied by baud rate. So n is number of bits per symbol. I have 2 bits per symbol. Baud rate is there are 10 symbols being transmitted. So I can say 10. Okay. So bit rate here is 20 bits per second. Are you able to follow this? So it is 20 bits per second. Okay. So remember, when two systems have to communicate with each other, so you have to make sure both the systems are following the same baud rate when the communication is happening, not the bit rate, it has to be the baud rate. Okay, I'm repeating again. So here, whatever you transmit in an instance of time, you call it as a symbol. So this is one symbol, this is another symbol. Okay, whatever you transmit in one instance of time, you call it as a symbol. So bit rate is nothing but n multiplied by baud rate. Baud rate means number of symbols you are transmitting per second. In the first scenario, I have 10 symbols being transmitted per second. So baud rate in the first scenario is 10 symbols per second, and each symbol is made up of a single bit. So bit rate is 1 multiplied by baud rate. So bit rate and baud rate are same in the first scenario. In the second scenario, I am again transmitting 10 symbols per second, but each symbol is made up of 2 bits. Okay, each symbol is made up of 2 bits. So at an instant of time, 2 bits are being transmitted. Okay. So bit rate here is, first of all, baud rate is 10 symbols being transmitted per second. So it is 10. Number of bits in each symbol is 2. So it is 2 multiplied by 10. Bit rate is 20 bits per second. Okay. So that is the difference between bit rate and baud rate, and the two devices should always agree to work with the same baud rate. Now, what happens if it will not work with the same baud rate? We will discuss in tomorrow's class. So this one slide, theoretically we will discuss, and then we will move to the programming part in tomorrow's class. Okay. So that is it. So we started with communication protocols. We discussed the theoretical concept of communication protocols. Then we started with UART in today's class. So programming part of UART we will start in tomorrow's class. So tomorrow you have class at 2 p.m. So we will continue to discuss the UART protocol, and we will see the program associated to that. Okay. So please have your attendance marked and quit. Thank you all. We'll continue tomorrow.